Yes. Okay.
Shall we start?
Yes.
Okay. So, thank you, everyone. Thank you for being here for our presentation. We will talk about Hadoop during our presentation. First question for you is, whoever in this room ever heard about Hadoop? Oh, whoa, cool. That's great. So that was just a quick question to know the level of our audience. So, technically, I'm Thomas, and I'm with Mahdi. We will talk about Hadoop concepts and security vulnerabilities. We are working on this topic since 2014, as we were first asked to perform a configuration review of that environment, and we literally jumped into that ecosystem, a complex ecosystem, and our work here will sum up our findings. So let's start, if you want. That's the agenda. We'll first talk about Hadoop and its security model, then how to prune a cluster, and then conclude with some wise recommendations and some a bit of step back for conclusion. So first, what is Hadoop? Hadoop is an open source framework to distribute process and to process stuff on large data sets using simple programming models. By distributed processing, we are saying that everything is mostly based on the MapReduce algorithm. So if you know Hadoop, you mostly know MapReduce, so that's cool. At the origin, MapReduce was used to sort and to index web pages. It was designed and described in 2004. That's not new technology, by two Google engineers. So the simple programming model here is using a map and a reduce. So you use a map function to process and to generate a key value pair, what would call intermediate key, and then you have to reduce a reduce function in order to aggregate and to consolidate results. That's for the MapReduce algorithm, the core algorithm used in Hadoop. Quickly on the ecosystem, although Hadoop is completely open source and free, backed up by the Apache Foundation, in real life, Hadoop environments are gathered around distributions, commercial distributions. So we have three main distributions. You have Cloudera, Hortonworks, and Mapper. Quickly, Hortonworks, the three of them have different positioning and commercial model, business models. Hortonworks only packages free and open source components. Cloudera add some closed source and high value added components. And Mapper does something really different than Hadoop. Is doing Hadoop without Hadoop, to be clear. But the common point between this distribution is they are using the Hadoop core framework, that we will talk about it just later, for data storage and processing. In real life, what does a real big data environment looks like? So at first you have a lot of CPU, then you have a lot of RAM, then you have a lot of storage. And then you put Hadoop core on it. And then, for the data lifecycle through the platform, you have different phases and different modules. So first, you have the acquisition. The most known and the most popular components are Apache Kafka and Apache Flume for that step. Then you have storage. In Hadoop core, you have HDFS. We will talk about it just after. For processing, you have a lot of stuff. You have Spark, MapReduce, and so on, and Yarn. That's it, and Drill, Apache Drill. For indexation, you mostly know, I guess you know Elasticsearch and Solar, I guess. So that's for the indexation phase. Then you have the consultation for end users, mostly. So you have some IPython notebook, named now Jupyter, U, Tableau, SAS, Splunk. I guess for security guys, you mostly know about Splunk. And then you have the administration, in order to orchestrate and to administer all the cluster. You have Cloudera Manager for the Cloudera distribution. You have Apache Ambari for the open source version of an administration interface. And then eventually you have what? Security. You have few modules in security. That's the point of our talk, and that's it. Few modules, and you have to integrate them along all around the data lifecycle scheme. So Hadoop core under the hood. three main components. The first is for the storage. As we've been saying this, everyone use HDFS. What is HDFS? It's a distributed file system. In Hadoop, it's very simple. Every data is stored in the form of a file divided in multiple parts, which you have the size on the screen, actual default part, replicated in multiple points. That's the core principle of HDFS. In Hadoop, you then have two different type of nodes. You have some data nodes holding actual file parts, and you have a single name node. At each moment, you have only a single name node which holds basically the list of the parts and their data node location. That's only a file listing. Then, for the processing, you have two components, the remaining two components, yarn and MapReduce. So MapReduce, you already know about it. We just talked about it before, to distribute the jobs. And then you have yarn, yet another resource negotiator, to schedule and to orchestrate all the tasks around the cluster. We won't dig. We won't dig in the component of MapReduce and yarn. That's really something complicated. It is worth a conference by itself. So you could doubt about what we've been saying. Really in real life, who uses Hadoop anyway? So you have some few companies using some nodes. You can see that maybe at the origin, Yahoo was one of the most popular users of Hadoop. You can see that the size and the volume they are using. Really, that's really what big data is like. You can see the metrics here, counting in teras and in thousands of nodes. Maybe at some point, maybe it was using, they needed that processing that computing power to parse and process mails. Who knows? Then Mahdi will talk about the security model of Hadoop.
Yeah. So now that you master the Hadoop main concept, I will talk about its security model. So first, let's talk about authentication. So basically, at the origin, no authentication mechanism was implemented in Hadoop. Or rather, only a simple authentication mode was used. So I just let you 5 seconds to read and find the mistake in this description. So as you can see, Hadoop won't make effort to authenticate user. It just want to verify if identity exists on a Hadoop cluster. So basically, if simple authentication is just you give a string with the username to Hadoop, and Hadoop, if the user is allowed to access the resource, Hadoop will allow you to view the resource. So this is the default mode for authentication. And then you have Kerberos. It's the only two modes of authentication. So basically, to a reminder, simple authentication equal identification and equal you can be whatever you want to be. If you want to impersonate user, you can impersonate, no problem. So if you want a proper authentication, the sole and unique mechanism is Kerberos, and it's a little bit complicated to implement all across a cluster. So now let's talk about authorization and auditing. So as Thomas shows you, there are a lot of components in Hadoop, and all of these components implement an authorization model, a different authorization model. And so it's very complicated for Defender to implement and to manage this authorization. For example, for the HDFS, the file system, it supports POSIX permissions like Unix. And since the version 2.5, it implements extended POSIX SL and extended attribute. Another component, which is Hive, which is a component used to perform. It's a SQL-like database, but on Hadoop. which support fine-grained SEL for SQL verb. For example, you can grant access for select, update, etc. to a user or a group of users. So to manage all these different authorization mechanism, you can use third-party components, which are also used to gather all the audit log and to simplify the managing the policy and audit trace. Yes. So you are, for example, Rangers on the screen and Sentry, which was built by Cloudera.
But one point on this topic, you have to know that we talked about distributions just before. You have to know that not every security or not every modules are compatible or at least packaged by distributors. Today, Apache Ranger is only available, supported by Hortonworks. So if you have a Cloudera cluster, you can, at your own risk, deploy your Apache Ranger. To be honest, it's not that complicated, but it's not supported. So if you want a central administration console, you have to make it at your own risk. So that's it.
Yeah. So now let's talk about data protection. So by default, no encryption is applied to data at rest or in transit, but natively Hadoop implement encryption. But to encrypt your data, you need to have Kerberos configured. So let's see, you recognize the name node here, the data node, and the client. So for data in transit, for encryption of data in transit, you have the connection and protocol used is RPC, and the authentication and security layer is SASL, which is used in 3 level of protection: authentication only, integrity, which is authentication and integrity, and privacy, which is full data encryption, including authentication and integrity. For communication with data node, so between name node, for example, between name node and data node, or client and data node, you have the data transfer protocol, which is used, and the key exchange is made by the 3DES or RC4, which is an algorithm, a weak algorithm with many attacks on it. And the data encryption is implemented by the AES algorithm. And for all the other service accessible through HTTP, you have SSL and TLS natively offered by Hadoop, but by default they are not activated. For encryption at rest, you have, so I remind you that you have to implement Kerberos. So each directory is encrypted in an encryption zone. So there are keys for this encryption zone. In these directories, each file is encrypted by a data encryption key, and the DEK, the EDEK is the DEK encrypted by the encryption zone key. Sorry.
Yeah, there's a lot of keys, yeah.
Many keys. And basically, when you want to decrypt data, you just ask the KMS, which verify if you have the right to decrypt the data. It will give you decrypt you the EDEK, and so you have the DEK, and you can decrypt or encrypt files. Okay.
Yeah, you have to understand that first we haven't performed any tests, and there's room for research, security research on this data protection in transit or at rest, to be honest. And the thing is, from the concept of HDFS transparent encryption only relies on ACLs on the KMS. If you can get your hand on the KMS, you can access the data lake as if there were no encryption. That's the point. You have to understand and to be careful about this kind of limitation. That's the concept. but we haven't performed any tests on it. I hope we will perform some tests later, but there's really room for research, for security research on these topics.
Yes. So let's talk about something more interesting now, how to pwn Hadoop, and we will begin by mapping the attack surface. So, like I said before, there are two main components, name node and data node, with a lot of service. And you have some interesting third party, for example, HTTPFS, WebHDFS service, which we will talk about just after, and Cloudera Manager, Apache Ambari, which is Apache Ambari, which are some administrative service, and they are sometimes affected by vulnerability we will talk about later too. So let's first talk about web interface, name node and data node web interface. Basically, the name node web interface allow user to get the configuration, to get the version, many information, and it allow user to browse the entire file system. So you can download file using the name node with a redirection on data node, because the data are stored on the data node using this HTTP interface.
So that interface, the first interface, is really useful. There's a lot of information that leaks in that interface. So if you can get your hand on this interface, you will have a lot of information, a lot of insights about the cluster, about its version, where are the data nodes, where is the global configuration, and you have a nice interface to browse graphically. We will see also just during demos just after.
Yes. So the next interface are used to manage job and task on the cluster, across the cluster. So you have basically the node manager, the resource manager. You can only view job history. You can view, for example, job status, etc. But you can't submit a job using this interface. It's just consulting interfaces. Not you can't do anything on the cluster using this. So next, the last one, last slide about web interface. You have these two interfaces on data node and name node, job tracker and task tracker. They are the oldest version of this one. If you see these interfaces, you may have an old cluster, and you may put it a little bit easier than the new one.
That's basically some GSP pages for this interface, and the code is really old. The last commit dates back to something like 2012. Take a look at the code; it will be interesting. There are really poor, from my point of view, poor coding rules in this interface. And if you can see if you can see them in a cluster, that's probably an old cluster. So maybe even easier to pwn.
So to sum up, to ease your work, some Nmap scripts have been developed. They can ease your work to detect data node, name node, etc. But you may be careful because these scripts are a little bit old. So, for example, you can see that these scripts allow to detect data node, job tracker, sorry, and job tracker is an old version, so you can maybe detect an old version of Hadoop, but not a new one. But you should use it because it gives some relevant information.
So, just mapping the attack surface, the point is that you saw, maybe we understand that there's a lot of information during this presentation. That's the point. There's a lot of services. That's the point. There's a lot of security and even modules in a big data cluster. That's the point. That was our first remark and our first concern when we jumped into that ecosystem. That's really complex, to be honest. There's a lot of stuff everywhere. And then, so one of the most interesting attack vector is surfing the data lake, accessing data on the data lake. What is the data lake? That's the HDFS file system, storing everything, basically. So, as a big data attacker, what do you want? Data. How you would like to access it? Through a browser. That's something really simple. You are lazy as us. So, you have to use the routing protocol called WebHDFS. As you may understand, WebHDFS offers some REST API to access the data lake. So you can access it through HTTP instead of the Hadoop client, the SIG client, as we can say. The API to perform any action. You can perform, you can erase file, create file, really whatever you want to do on the data lake. There's no limitation from the API. Where can you see some WebHDFS services? Mostly on two components, on the data node, on the port, on that port, and on a third-party module called HTTPFS module, which basically only exposes WebHDFS. That's the only role. So as a defender, you could say, yeah, I will filter any flow to that port on the HDFS data node because it's not meant to be exposed. But at the same time, you could maybe expose that module giving the same accesses, maybe for business or for data scientist needs. You can deploy that module, and it's totally the same. It exposes the same API on a different port. Okay, now if you remember what Mahdi said about simple authentication, if you accumulate a simple authentication and you can see some services, basically you can access everything you want on the data lake through a simple parameter called user.name. You can specify calling the API the desired username you want to be, and you can access anything on the data lake. That's not a bug, that's the authentication feature. That's called simple authentication in Hadoop, and that's by default. So, demo time. So basically, here, what you will see is first the first web interface, which is, as I said, the most important. That's that interface, basically. The first page is that. You can have also, you can see a lot of information on it, the version and whatever. And here in utilities, browse the file system. You can browse the file system. Wow. And you can browse, so you are on the distributed file system on the HDFS, basically. So as the same as on Linux and whatever, you can browse and go to any file you want. And if you go, for our test, if you go to HDFS, here you can see a permission, an error, a permission error. Because we are not, through the interface, we are someone called Doctor Who. That's the default user. And you can see that we wanted to access that directory. So under that graphical interface, what is really made is a call to WebHDFS API. So basically what we've been doing by going to attempting to access /user/HDFS, we were doing that request. So here you can see the operation. You have open, list status, delete, and whatever. You can see the documentation on the WebHDFS page. And here, as I told you, if you have simple authentication, you can do something really dumb like this, and you can also then browse the directory because you specified which user you wanted to be. Here, that directory was restricted to its owner, so HDFS. So you can access it through that parameter. That's the consequences of the simple authentication. So here you can see in the response that there's a file called hack.lu, so you can access it. Now, going back to the presentation, so that's it. You are able to browse and to use the WebHDFS API to access whatever you want. I will show you just after what is how you can really access the file through a different method, a similar method, but different. For that purposes, we've been also developing a script called the HDFS browser that simply lists. That's really something interesting for attackers to be able to list any file on the data lake. So basically, you call this, and here you have a listing calling the WebHDFS API. That's something really dumb, but we made it because it was not existing. You have some several options like .r for recursive browsing, and here you will have a nice dump on everything what is stored on the HDFS. So you can see a lot of file. That's not the point here. So, going back to the presentation, sorry. So as I said, for an attacker, it's really important to access and to be able to list the complete file listing. So we've been developing that tool. Now, if you still want to access data, but through the SIG Hadoop client, CLI, you can, instead of the user.name parameter, you can specify an environment variable called Hadoop username. Yeah, that's done. And so you can perform the same and access it through the client. Again, some demos. Another screen. So I will take this. If I want to access that file, I should be disallowed. No, we're sorry. Permission denied, because as we are the root user, we cannot access that file. Now, specifying that environment variable and stating that we are HDFS user, we can simply list and access that file. That's the same result you can have with WebHDFS. There's nothing more, nothing less. So I'm listing the file with this permission, and I'm displaying it because I'm allowed to display it, saying that I'm the HDFS user. So that's one vector, the first vector, being able to list and access file on a data lake. Now something more interesting, how you can execute some code, really. How can you have some shell on nodes because of no authentication and the MapReduce task and principles.
Okay, so basically, Hadoop is a framework for distributing process and basically distributes tasks to execute. So what we want is to execute code on an infrastructure which was built to execute code. But how can we do it? So
in the standard way, in the formal way, you have to develop a MapReduce job. Developing a MapReduce job is coding Java, a Java program, and then something really useful that Mahdi will talk about it appeared in order to wrap that kind of MapReduce jobs and to ease the data scientist life.
You have a module called Hadoop streaming, which is used to launch any executable or any script on a Hadoop cluster. You can so let's see the command. So like before, you have the Hadoop command. So you specify a jar file. The jar file is just a Hadoop streaming jar file, which is in the default package of Hadoop. It is so available on every cluster. And you just have to specify an input file on the HDFS file system, an output file, a mapper, for example, cat etc password, and a reducer. So to be a little bit more efficient, we just put reducer none because it's not useful for our case.
And it gives you, it reduces the time for the data attack. You don't need a reducer. Maybe we will need a reducer if you have some more complex attack, but just to execute a single command, you don't need a reducer. Just a mapper is sufficient.
Yes. So this launch the MapReduce job. So then, after the job is finished, you have to check if the job was successfully ended. So you just list file and check if your new file was created.
You have to understand that executing a command does not give you an output. There's no output on Hadoop. Everything is file. You have some file as input, some file as output. You don't have a display on your shell directly. You have to display and to cat some files.
Yes, you just have the error. So, and then if the all is good, you can cat your file and see what you have inside. So this returns the job result.
So that's first one point. So as you can see, we will be doing a demo just after. So executing a command is good, is great, that's cool. But you can, I think, do better with Metasploit and ease your penetration testing phase and use a Metapreter. You can totally do it with Hadoop streaming. So that's what we will be showing you using a Metapreter.
So yes, to simplify the task of executing command, you choose to take a Metapreter. So just use MSF Venom to generate your payload. We choose just bind TCP. You can use reverse TCP if you want.
Yeah. If the network flows allows you to have a reverse or,
yes.
or direct connection, do whatever you want. There's nothing specific to Hadoop in the MSF Venom yes. Payload generation, not even in the second command, but in the third command is really specific to Hadoop, and you have some tiny options not to miss in order yes. to have your job executed.
So it basically is the same command that the one before, but just you specify the mapper, which is MSF payload, and you specify the file because it's a local file, not on a GFS file system. And you have to specify a background parameter because if the job takes too long time to execute, the yarn will cut your job and you will not have your shell. So this starts the job without waiting for its completion. So demo time.
So basically, we will be executing a payload. We have basically one virtual machine as a Kali, with Kali as an attacker machine. We have our server on VMware, and basically we will be executing because we can see really the two vulnerabilities are that the fact that you can see any port, there is no network filtering. That's a strong measure and a common measure. And you have simple authentication. And even if you had Kerberos authentication, if you are allowed as a data scientist to execute some task, you can do what will be doing. Basically, a data scientist only execute tasks. That is jobs. No pun intended, but that is jobs. And the thing is, so any data scientist can perform some Metapreter on this infrastructure.
So we have the payload ready. So just check up.
That's an elf, something
yes.
really done.
So we just basically copy paste the command.
The command we've been showing you just before. And here.
So the job is submitted and is running into background.
So here on the server side, so just to be clear, that's something you don't have access to. Wait a minute, but you can watch you will see the time the task takes to execute. Maybe on your Metasploit. Yeah, we have everything set, so don't think it's magic. But here we are starting the job. The Metapreter should be executed, and we are just waiting for it to be executed.
It's very slow because not because it's in a virtual machine, but mostly because it's Java.
Not troll, but really MapReduce tasks are really old stuff and legacy stuff, and it takes time to execute MapReduce jobs. Now you have quicker jobs, which are called real-time jobs. There's not really real-time job, but they are mostly based on Apache Spark. I guess you already heard about Spark if you heard about Hadoop. That's in-memory management, in-memory jobs. Contrary to MapReduce, which is using input and output file on HDFS, and it takes time to read and write.
I have to interrupt Thomas because our shell is okay and was run on the cluster. So we got the Metapreter, so we can use shell. And if you see, who am I? I am Yarn, the user used to launch task on the cluster.
So that's the point. So here we have a common and plain interpreter, so you can then route your traffic onto that cluster and perform and continue your penetration test.
Okay, so now this was some limitations as as it is you can't control on which nodes the code will be executed, because you can just give some job to Yarn, and Yarn distributes the job. So
yeah, that's the point. We've been trying to find a way to target specifically one node, and you can, because that's the point of MapReduce and Hadoop. You don't have to worry about where the task will be distributed and executed. Hadoop takes all that pain for itself and distribute stuff. You cannot, so far, we haven't been finding a method to target one specific node. So basically, you've got a shell, you've got a RCE, but you don't know where. You only know that's a Hadoop node.
Yes, that's why maybe reverse CCP could be maybe better in some kind. So, and you have to in order to execute command with using Hadoop command, you have to set up an environment configuration, and for that we have some methods. So we have the /conf that we shows you on the HDFS browser, but it is available on almost every interface. So if you got an Hadoop interface, try /conf, and you will have the configuration of the cluster. And on a third-party component, we found a vulnerability which allow user on Cloudera Manager to download configuration. So you can use this. And to ease your task, we developed a tool called Hadoop Snooper, which basically build for you minimal configuration to run job, to access HDFS, etc.
Yeah, so that's something really important. Having a proper and working Hadoop configuration can be a pain, and when you don't have time to dig the documentation, you are really lost. And that's our task to produce that tool, because we've been digging that subject through since 2014. So we know which parameters are needed for an attacker to perform, to launch tasks and to browse the file system.
Yes, because there are a lot of parameters on Hadoop.
So you can, again, you can say, okay, that's cool, we can execute whatever we want, but maybe this kind of infrastructure is really protected in corporations. I don't know, I will just share with you two screenshots on Shodan. You can find some Hadoop clusters freely available on the internet. Maybe there's no authentication on them, I don't know, but that's something really common. And to our point of view, we don't think that people are really conscious about the consequences of exposing a cluster on the internet, because it's basically free remote execution, really, as we've been showing you. Then, as you've been saying again in the big picture module map, there's a lot of third-party modules, and that's mostly web modules, and there's a lot of vulnerabilities in them. What we've been saying during this part, I will be quick on this chapter. Really, there's a lot of classical web vulnerabilities. That's really a shame, to be honest, and that gives you a strong insight of the maturity level of such components, of such ecosystem. To be fair. So basically, here something really interesting on the management interface of Cloudera. You can have a listing with the unprivileged user. You can list everyone and have their remote address and if they are active on the cluster. Here you can access any standard error or output process log. So any task you can have, you have to just iterate on the process ID. You have any information you want. If the developer thought it was good to put passwords on his logs, then you have them. You have a lot of XSSs. For Cloudera U, which is a data visualization module, you have some authentication and control access issues. You can list user. You have a lot of XSS, really plain XSSs in the first name and last name field. To be honest, you have some open redirect. That's cool. You can trick your colleagues, your data visualization colleagues and your data scientist colleagues. And then we'll just stop on Apache Ranger, which is the only maybe security modules in the Apache Hadoop ecosystem. You have not a variety of feature, I guess. You can download the policy free, being unauthenticated. So you just have to guess the policy name. That's the RDS task on exploiting this flow. Again, this is not a vulnerability as it does not give you direct access, but it's the same as if you were downloading a firewall policy. You have a strong insight and a lot of insight of the possible potential holes in the system. So you can see basically who's allowed to access any data on the cluster. You have the policy, and so then you can perform some map diagrams to see where you should be going. And then another stuff, you can see we found a simple, stupid SQL injection that can give you user credential, or better, you can dump user cookies, user session cookies. That would be better to dump that second method, because you can access and reuse them on the interface without cracking and trying to crack some hashes. That's it. That's the level of security modules. That's the level of security for security modules in the Hadoop ecosystem.
So we worked on the Hadoop security. If you want to join us in our Safari, use the prepackaged Hadoop environment, for example, Cloudera or Hortonworks. We didn't test Mapper environments. Not yet. And if you want to download our tools, you can have it at this address. Yes, you have a GFS browser and later get configuration.
Also, along with tool, you have some tactics and procedures. Basically, a summary of our presentation in textual file, giving you insight of how you should be performing your test. Really, that's some tutorial, if I could say, along with tools. You don't need a lot of tools. Basically, you need a working Hadoop environment, but there's a lot of insight about the procedures. So now, taking a step back, to be fair, our first goal was to assess the maturity level, the security maturity level of that ecosystem, as I've been saying through this presentation. First, you can say that that technology was not built upon security. Should I really have to persuade you with simple authentication, which is identification, without any encryption by default, without any native encryption for flows or data storage. Then you have a fragmented ecosystem with distributions. Everything is supposed to be open source, but you have some distribution, as we've been reviewing with Cloudera, Mapper, and Hortonworks. And some security solution may not be available for your distribution. That's it. There's a lot of immaturity in security development. The SQL injection in Apache Ranger, which is the sole security modules, is quite astonishing. And to top it all, there's a complex operational security. There's a fast pace for modules, third-party modules. They are basically developing and releasing a lot of versions easily and quickly, but the distributors takes a lot of time to package them and to give them to clients. As an example, HDP, which is the Hortonworks distribution, was shipping in March a one-year old version of Apache Ranger. That's it. And maybe the biggest challenge for corporations is to patch, is to maintain a cluster in operational security conditions, mostly for service disruption concerns. To date, with Mahdi, we never saw a patched cluster that. To explain myself, a corporation deployed Hadoop clusters and never patched them, to be fair, so far.
So last word for the defensor. please use Kerberos on your cluster. Then reduce service exposition. Don't forget HTTP interface or native Hadoop service. Don't give free shell on internet or wherever. And last but not least, try to harden component configuration and to keep up to date your cluster and the technology. So,
thank you, Guy.
Thank you. If you have a question,
we are at your disposal.
Questions? And for the gentleman who's leaving, I'll let you know that there's sandwiches and beer outside waiting, but questions first?
You found many vulnerabilities here. Have you reported them to Apache Foundation?
Yes.
Yeah, all the shown vulnerabilities have been reported. And I don't know, patch, I don't know.
Yes, but the most part of our presentation is not on vulnerability, but on just Hadoop feature.
Yeah.
Because for example, the remote code execution is just
you can patch this. Yeah.
There is no patch.
That's the concept and how to use Kerberos and how to use Hadoop. But yeah, for vulnerabilities shown here, for Apache Ranger, yeah, they are patched. But don't forget that it takes time to patch your cluster and have your distributor to provide you a package, a patch package. So maybe your cluster is still vulnerable, maybe. But the latest version, yeah, the vulnerabilities are fixed. But until you have the latest version on your cluster, it's not today.
Yes.
If no further questions, let's give them a big round of applause.
Thank you.
Thank you.